Hello everyone. Can you guys hear me okay? That's the second stream for us. Just finished setting up everything. The camera sounds okay. Okay, and how about the sound? Can you guys hear me well? Have the microphone just here. Let me remove this. Yes? Awesome. Santiago, hey, how are you? Coley Logan. C3DS, custom 3D specialist, hello. Awesome, thank you guys for joining the stream today. So today we are going to talk about a lot of things, basically pretty much all the materials. And I hope you guys have some questions, and then we'll just answer. I'll just go through the portfolio one by one, trying to explain a little bit more about our different materials, and then I will try to keep an eye on the chat, and then if you guys have any specific question, then I will just stop and then just answer the question the best I can. Santiago, yeah, I'm very good, thank you. It's 9:30 here in the morning. How about you guys? So where are you based? Are you all from the US, or is there South America, Europe, maybe Asia? Morning. Translucent red TPU95 HF. Yes, actually that was one of the first that we developed it for shoe uppers. We haven't released it yet with our standard, but it's something we can consider definitely. Any giveaways today for the holidays? Maybe around an hour and a half. And there will be some giveaways indeed during the stream. So we have people from Canada, Ohio. So I guess in the US it should be somewhere in the evening. I think East Coast somewhere around 8:30, 9:30 in the 8:30 in the evening, and I think Pacific time somewhere around 5:30, end of afternoon, I guess. Okay, USA 8:30. Yeah. So did you guys have a good Thanksgiving? So I come from a French Pacific island. So we do not have the Thanksgiving. For us, Christmas is the day where we gather with the family. We don't have the turkey, but we have a lot of things to eat. But I hope you guys had a very good Thanksgiving. I believe it was yesterday evening for you. Hey, Oriana. So Oriana in the chat is our marketing manager in the team. So she helped setting up the stream. Okay, great. We have a couple of questions. So I will just answer this question first, and then I will start talking a little bit more about the different materials. So Josia asked about black and white PolyLite PC. We used to have actually black and white PolyLite PC. It was called PC Plus at that time. We discontinued the black and white mainly because for PolyLite PC, which is a non-modified PC compared to our PolyMax PC, people were more interested in the translucent color. And then when it came to having black or white, as the mechanical properties were much higher for PolyMax PC, then we decided that for other colors, people would just go for PolyMax PC. So PolyLite PC, one of the reasons you could go for that one might be for the rigidity. It has a slightly higher rigidity than PolyMax PC. So rigidity meaning if you tend to bend the material, then PolyLite PC will have more resistance to bending than PolyMax PC, but very, very slightly. Overall, PolyMax PC is almost similar with much higher overall mechanical property. Then we have, I noticed, best setting for PS6 GF. I think I do have some PS6 GF somewhere. Yes, This is a mold made with glass fiber reinforced nylon 6. Best setting. So one thing to remember with our PolyMide family, so all our nylon-based material is the warp-free technology. Why I mention this is because if you do have experience with other nylon, you may have experienced a lot of warping issue. And usually you solve this by increasing your bed temperature or increasing the chamber temperature. However, for our particular nylon, that's the exact opposite. We have formulated a technology that allows you to print your nylon parts without any warping issue. However, if you increase the bed temperature or the chamber temperature, then you will start to have warping issue. The simple explanation is we are playing with the crystallization behavior of the material in order to control the warping. So we control the internal stress accumulation within the layers, which will control the warping. So if you stay below 50 degrees for your bed temperature or overall chamber temperature, then you won't have any warping issue. For the nozzle temperature, you can go 280 to 300. So you will be needed a whole metal hot end for printing with GF. And please remember to use abrasive resistant nozzle. And I would also recommend to use it for the drive gear for the extruder if you use it a lot. So actually, to show off the warp-free technology, we have this cube. It's very heavy. It's 100% infill. That's you can hear. It's like a massive cube of copier. Well, not the best way to use additive manufacturing to just make a cube, but the idea was, what was the idea? The idea was to show off our warp-free technology. So this was printed, I believe it was on the Ultimaker 2 Extended Plus. So we printed this one, so no heated chamber. The bed was at 45 degrees and we used a glue stick, and that was the result. So you can see there's no warping at all. I hope you can see well. You see, it's dead flat. It's very, very flat. So that's kind of that's the best way to show warping. There's no way, for example, you have let's say a polycarbonate. There's no way you can do this. So why we are so proud of our nylon? It's very simple. You take very easy to print PLA. TG is what? 60 degree. So let's say heat resistant 60 degree. PETG, a little bit harder to print, like a tiny bit, but you do have a tiny higher heat resistance, like 80 degree. ABS, much harder to print, but you have 100 degree heat resistance. PC, more challenging to print, but you have 10 degree more, 110 degree heat resistance. So you have this kind of correlation between the heat resistance you can get out of your material and the printability. And then comes our nylon. 180 after annealing heat resistance for very easy to print. So that's why we are so proud of this warp-free technology, because we broke that correlation between you want heat resistance, well, you're gonna have very challenging prints. No more with our PolyMide products. So I hope that answered the question. For the best settings for glass fiber nylon, and then we have print. You mean the massive cube? Well, I think we printed that 2 years ago, but I don't remember. But the layer height is 0.2. I mean, it's not like we printed. You can see well, you can barely see the layers. Sorry for the good filament. No, just kidding. But it's 0.2 layer height. It's 100% infill. I believe, I'm not sure, but I would say a good 2 to 3 days, if not more. I mean, we're talking about what? Maybe I guess it's a 25 centimeters by 25. Well, if there's people from the US, I have no idea how many inches, but yeah, that's my hand. I mean, I have a big hand, but yeah, 25 centimeters by 25 centimeters, 100% infill, 0.2 layer height, and the extrusion width was 0.4. We use just a default default profile, default setup, 0.4 nozzle. And what else do we have? Will the cardboard spool affect the price of the filament? Will the cardboard spool affect the price of the filament? Okay, I understand. So it's a very good question. Actually, before we wanted to switch to cardboard spool, the first thing we wanted to do is not affecting the price. You know that, you may know that the cardboard spool is may have a higher cost than a regular plastic spool that you can just injection mold, and it's a very mature industry to produce this plastic spool, and the supply chain is very mature. So you can drive the cost down by a lot. And changing to cardboard spool at that time, this project started 2 years ago. We had the issue of, if we switch to cardboard spool, then all our price would increase. So we worked out a supply chain that would allow us to keep exactly the same price. So right now we are still in the transition between plastic spool to cardboard spool, but the end point is that the price stay exactly the same between the plastic spool and the cardboard spool. So that's actually our new packaging. You can see what we have on the sticker. Oh, actually, so you guys should see the mirror video of what I have, right? How do you guys read Polymaker here, or do you read Rika Milop? I think you guys read the right one. So if I show like this, you should be able to see it properly. But basically now you still have all the printing setting. You still have the weight scale that we introduced, I think four years ago, 4 or 5 years ago, and the feedback was amazing. You guys really love that weight scale, or gauge. And then now we have the product information. So before we used to have the product info sheet. We call this the PIS with all the information. But that was a lot of paper that we put. And then let's say you like one of the filament, and then you buy repeatedly that same filament, then you always end up with that product info sheet. So what we thought is, let's save some paper, and then let's just have a QR code, and then you can just scan with your phone, and then you have all the PIS in a digital version. Another one that come from our customer. Basically, all the idea you have here come from you guys. And thank you very much for all the suggestions. So we had a customer that asked about the spool weight, because I believe they wanted to know, how much filament stay on the spool, and then they would just weight the filament, and then they would remove the weight of the spool. But the problem is they didn't know the weight of the spool. So we just put you see the spool weight, which is 200 grams for this one, and the net weight, which is 1 kg. And then you can also check if we did our job properly, and you have a net weight of 1 kg on your spool. Other things, we have the fan. Usually you will see the printing speed, the printing temperature, and the bed temperature, but you won't see the fan. So we have the fan. Right now it's on and off because most of the common printer don't have a huge difference between 0%, 50%, 80%, 100%. But there is some printer that at 100%, it will just, it will be very, very powerful. So theoretically, we should put a percentage, but we believe that for most of the printer, it's either on, either off. What else do we have? You have, do you guys see any? Do you guys speak any language that is not on our spool? So we have 3D printing filament. Other languages that I don't want to mess up the pronunciation, but we try to have in international way of saying 3D printing filament. We actually had I think 2 years ago we had a mistake on the Arabic one, but a user really nicely came to us and gave us the right translation. And then at the back you have all our portfolio. And this is very important. The small white thing, white sticker that you see here. Can it? Sorry, it doesn't focus. But basically, this has all the information that we would need if you have any issue with the filament. So we keep track of all the batch that we have. So if you go in our factory, we have samples of every single batch that that we have produced to check. We check a lot of things, but we check the melt index, the color, etc. So if there is any issue, then we would ask this batch number and SKU number, and then we will go back, and then we are going to check what went wrong, and then we may recall that particular batch. So quality is very, very important for us. And yeah, and then for the box, some changes, some small changes as well. You have the stickers. This one is pretty much the same, but we have happy printing. I think that's a pretty nice touch when you receive your spools and then you're ready to make awesome models on your printer. And actually, there is another hidden message inside, but I won't show it. You guys have to find out. So that's for our carbo spool. Will there also be a PC filament that resists up to 147 degrees? We actually already have one. The challenge is to release a filament that users can use. And we do have, I think the highest we have is our PC PBT. This PC material, so it's a blend between polycarbonate and PBT. It's a very nice model, actually. You know, it's the how do you call that? The pedals, pedal shoe holder, I guess. Very, very good quality. So this one was printed on the Method X, the you know, the MakerBot printer with heated chamber, and we printed that with our PolyDissolve S2 to support the PC. So it's a warm alkaline water dissolvable material, and this one can resist up to 130, if I remember well, 25 or 30. But it's very challenging to print. Very challenging means you need 90 to 100 degree heated chamber. You need to print this a little bit slower than regular, like 40, 45 millimeter per second. But the result is amazing. And the particularity of PC PBT is the chemical resistance and the low temperature toughness. So if you go in winter, if you go cycle outside in winter, then it will keep 80%, I believe, of its toughness, rather than a regular PLA. If you put it in the freezer, and then it will just shatter. So and the other one we have is PCR, which we will release next year. We talked about it already this year, but it's a specific polycarbonate that use 50% recycled PC. You know, those big jar or like the bottle that you put on top of the fontaine, like the blue bottle. Then we recycle this. 50% are recycled in order to make our polycarbonate. So this one also have a high heat resistance, but it's more challenging to print. So in order to release that polycarbonate that would have 145 heat resistance, then we would need to have a way to suggest people to print it. So we need to recommend a printer, and recommended a $100,000 printer by being the only way of using that filament. We want to find a better solution. Why does PA6 have better mechanical properties than PA12? Are the chains longer, maybe more entangled? And what's the difference between 6 and 6.6? Thanks in advance. So the mechanical properties. So it's very important to understand what mechanical properties and how they were tested. I believe Santiago said that PA6 have better mechanical properties than PA12, maybe by comparing the dry state of the material. We do have one of the version of the TDS that have the wet state, so which means after, let me check if I have any prints that are CF around here. Maybe no, I don't have. So the TDS that we had before had how we put it in a wet state. We were putting it in I think 70% humidity for 3 days, and then relative humidity for 3 days, and then we would take again the mechanical properties. So you know that nylon would absorb moisture, and then it would act a little bit like a plasticizer. So it would make it would reduce the modulus, reduce the rigidity, and increase the toughness of the material. For PA6 CF, it has 20% carbon fiber by weight, so it is very, very rigid. However, it absorbs much more moisture than PA12. So in the second version of our TDS, we put the PA6 in water, PA6 CF in water for 3 days, I believe 3 days, or maybe 1 day, I don't remember, but enough to saturate the water. And then we did the same with PA12. And after we compared the mechanical property, then PA12 was much higher in terms of rigidity than PA6, even though PA6 has 20% carbon fiber in by weight, and the PA12 CF had 10%. So at the end of the day, if you use our reinforced material and you want its rigidity to be as high as it can in let's say regular environments, then PA12 might be a better solution because it won't lose its rigidity over time, rather than PA6 CF will start to absorb moisture and lose its rigidity. However, if it's a very specific environment, let's say operational temperature above 100 degrees, then PA6 CF might perform better than PA12 CF, because now the moisture doesn't influence the mechanical properties. So I hope that that answered the first question. The chain longer, so it's longer in 12. If I remember well, the number is related to the length of the polymide, the polymer. Maybe more entangled. And what's the difference between 6 and 6.6? The difference, so we don't have a 6.6 pure material, right? The one we have is called CoPa, so it's a blend between 6 and 6.6. I don't know the exact difference in terms of molecular composition, but what this copolyamide 666 brings is the printability compared to our PA6. So it reduces the printing temperature. So you can print our CoPa at 250, 260, but the PA6 has to be printed at 280 to 300. Hi, 3D Musketeer. How is it going? Very well. How about you? About 10.5 inches. Yeah, okay. So that big cube is 10.5 to 10 by 10.5 and 10.5. Actually, it's really heavy. I don't have a scale, but make it all good. Okay. I'm trying to catch up with the chat. How's layer adhesion of PC PBT compared to PolyMax PC? You know, that will highly depend on your on your printer. If you are able to print with the best setting for both, then they will have similar layer adhesion. So for polycarbonate, when it comes to layer adhesion, it basically comes to what equipment do you have. If you have the perfect equipment, like 100-degree heated chamber, you can print at 2/7 stable. Please wait a while. We try to reconnect. Can you guys? Hello, hello. Can you guys hear me? Looks like I should be back by now. Sorry, it looks like it just connected for a few seconds. Yeah, so comparable if you have the right equipment. If you have the same equipment, let's say if you have an Ultimaker, a Flash Forge, or even a Creality printer with a all metal hot end, you will be able to have a better layer adhesion with PolyMax PC. Why? Because PolyMax PC would be easier to print on those printer than PC PBT. So that would answer the question with a little bit of how you call that, like depending on the situation. Will this live stream be released? Yes, yeah, it will stay on the channel. Actually, talking about live stream, if you like this kind of live stream where we just go over material, products, 3D printing, let's talk about 3D printing. Then we are going to launch in 2 weeks a weekly live stream every Thursday night. We are going to have just a 1 hour live stream where we just answer some questions. The goal is, if you have any issue with our materials, if you want some troubleshooting, if you want to talk about 3D printing in general, if you want to talk about new materials, so we will have this weekly live stream, and you are very welcome to join. So we will launch that in 2 weeks. I hope it is. There is a lot of good information. And we hope. I mean, thanks to you guys, thanks to your question, we have some topics to talk about, and then I will try to expand a little bit the topic in order to include some other information. Why is PolyMide CoPa more expensive than PS6 GF? So you have to consider, I think CoPa comes in 750 gram, and the PS6 CF and GF actually come in both 500 gram and 2 kg. So depending on how you produce the filament, there would be some differences in prices. But if you make the calculation from that 500 gram, you will see the how the price structure goes. We try to keep our material as cost effective as we can. It depends on how much filament you guys need. It depends also on how we design that particular packaging. So prices depend on a lot of things, not only the price of the material itself. What raw materials goes into CoPa, what raw materials goes into PS6 CF or GF in that case. Actually, a lot of people ask, when should I use CF? When should I use GF? I think I would say objective/subjectively that this is like a spectrum of price property. You want high performance, you go for CF, and then you go for less budget friendly material. You want your application requires, doesn't require such a high performance, then you go for GF, much more cost effective. So it's kind of it's a spectrum of they can deliver similar performance but on a different scale, and obviously the budget will go with it. Why does CoPa not like overhangs? How to fix it? Good question. Any material that we usually don't recommend the fan, such as CoPa, PC, PC PVT, PC ABS, will usually suffer from overhang quality. The main reason is, how does overhang works? You have, I think in I don't have here, but in Sean's book, 3D Printing General on YouTube, he has a book, and then we work together on the material science chapter, and there is a whole section where I talk about overhang and what's the science behind overhang. So you can get the book to go more into details, but to summarize, you need the filament to get a certain rigidity when you print in order to hold that half overhang situation. You're printing basically in mid-air, half of it in mid-air. So in order to avoid the drooping, or in order to avoid the curling, because the curling is also a problem with printing in mid-air, because there's nothing to stick with. So if the filament shrink, then it will just curl up, or if it droops, then it will just droop. And in order to fix that, is you have to find the right balance between printing and directly solidifying on the spot. So, and then you use the fan in order to do that. I posted on our Facebook group, the Polymaker Facebook group, I posted a difference between, but I think that was ASA. That was ASA with zero fan, like a very steep overhang, and then you had this issue of curling in that case. And then I put a 10% a 10% fan, like a small breeze, and the overhang was just perfect. So my recommendation is try to put a little bit of fan. If you're still looking for very high mechanical properties, then don't increase too much the fan, but have that small breeze that's going to help reinforcing that filament that were just printed in order to solidify the overhang. If you're already using a fan and you still have this problem, then try to understand if it's drooping or if it's curling. And depending on this, then you may have some other suggestion. Like if it's drooping, then you can try to increase the fan speed, or you can try to increase the printing speed. It's hard to summarize without going into detail, because printing speed is related to the temperature as well, right? You have printing temperature and actual extrusion temperature. I think CNC Kitchen, Stefan from CNC Kitchen released a very nice video on it that shows it's not because you put 210 in the slicer that the filament is actually going to be printed at 210, right? It will depend on the printing speed. If you print at a crazy high speed and you put 210, most likely the extruded temperature is going to be 200 or 190. So there is this correlation here. But hopefully during that weekly meeting, weekly live stream that we are going to have 2 weeks ago, then we can really go into details on all of this more technical material science point. What would be the best filament for printing with smaller nozzle like 0.2? PolyMax PLA, definitely. Why am I saying this? Is because we do have, actually, there is a perfect video that also CNC Kitchen released, I think last week or the week before, and he used a 0.1 nozzle, if I remember well, from a Japanese manufacturer, and then he used PolyMax PLA for that purpose, because that was the filament that would give him the best result from his video. I think it was recommended from Richard, I think, that was already printing with small nozzle. Why I believe PolyMax PLA was the best one? Multiple points. The first one is, I think, the jam-free technology. You know, as you're extruding very, very slowly, you know, because if it's a 0.1 nozzle, then you really extrude slowly. The filament is basically not moving in the extruder. So it's going to stay in the hot end for a long time. And what's the problem? Is if it stays for a long time, then the heat from the heat block is going to climb through the filament to the cold hand. And if the filament in the cold hand is above 60 degrees, which is the TG of the material, then it will start to expand and soften, and then it will jam your printer. So why our jam-free technology help with that? Our jam-free technology, you have the filaments. It's funny. I'm in the filament manufacturer and I don't have filament around. Oh yeah, I have. So we take the filaments and the actual filament. So what is this? Yeah, PolyLite PLA. So this particular filament has a heat resistance of 140 degrees. This particular filament. After you print, it goes back to regular heat resistance, which is the 60 degrees. But the crystallization behavior of PLA allows us to create filament with a very high heat resistance. So if this filament is 140 degrees Celsius heat resistance, then you are not going to have this heat creep problem. So that's one of the reasons. The second reason, I believe, is the diameter accuracy. You know, if you're printing with 0.1, you need the software. You know, the software is going to tell, okay, you need a 0.5 millimeter extrusion. Then he's going to calculate that your filament is 1.75. If the filament is a little bit out of this 1.75, then you won't have a very good quality print, because it will extrude a little bit more, a little bit less. So I think that that's one of the points. Another one, which this one I'm not too sure, but it's just the formula of PolyMax PC, PolyMax PLA that makes it easier to print in a way that I believe this one I'm not too sure, but I think the melt index of the material, or the viscosity behavior, or like, you know, the way it flows, the formula we use makes it easier to flow. But I would have to double check that. But definitely PolyMax PLA for 0.2 nozzle, it's good for 0.1. So definitely for 0.2 should be no problem. And we actually had a partner. We have a partner called Mass Portal, and I think 3 or 4 years ago they printed a watch, a real watch with all the how do you call that? The gears inside, you know, all the mechanism. They were all printed in PolyMax PLA with a 0.1 nozzle, like, you know, these tiny gears and things. So I do think we should have some pictures around. I will try to post one on the social media about that that watch that they printed, but really amazing. PS6 GF per kg is still cheaper than CoPa per kg. Yes, yeah. So GF, sorry, maybe I read CF before, but definitely GF, like we said, is more in the budget-friendly spectrum of our nylon. Great answer to CoPa. CoPa is 55. Okay, so the calculation, yeah, okay. Will there be an easy to print polypropylene, I guess, or polypropylene CF, or PPCF filament? So we do have one material that is coming. I won't be able to talk much about it for this stream, but if you are here in 1 month, then I will talk more about that material. It's actually a very exciting one. Good that you mentioned this, but it's exactly one of them that we are going to release, and easy to print, definitely. We found, you know, we talked about something about our nylon, and we managed to do that with some other filaments. So pretty exciting on that part. What's your favorite color of Polymaker filament? Well, I'm required to say teal. No, I'm joking. I like the teal. Personally, you know, my very first filament that I used was actually polycarbonate. So the PolyMax PC. Do we have any PolyMax PC around here? No, we don't have PolyMax PC. But the PolyMax PC was the very first filament I used. Before I joined Polymaker, I was in a startup that was printing pollution mask, and I was printing these masks in polycarbonate. And I spent so much time with that material, and I nailed it down to printing like just so nicely. And the white was the one I was printing. And if you print PC in white, it has this kind of shine to it. And yeah, I just love it. So I like the teal, and I really like the PolyMax PC white because of the effect that it has. I think on the group, I also post some picture when I print with PC. That's my favorite filament, PolyMax PC. PCCF maybe. Yeah, so polycarbonates, carbon fiber reinforced. So I had a talk with our R&D about that material. You know, I talked about the fact that some users was asking for it. And then the question they ask is, why users would want CF in the polycarbonate? So maybe a straight answer would be, well, we need it because it reinforces the material and it gives more mechanical properties. So from our experience, the CF in the polycarbonate will help with the warping behavior. It will help with the dimensional stability, but might not help that much with the actual mechanical property, like giving more modulus, giving more strength in all axes. However, this is not something we have tested, but it's just an experience that they shared with me. So if you're looking for PCCF, then you can try to let me know, you know, what exactly you're looking for. Are you not happy with the current PC because it doesn't have enough impact strength or tensile strength, or maybe a layer adhesion? And then depending on what you need, then we can see if the real solution is to create a carbon fiber reinforced version of our PolyMax PC, or maybe a different material or a different version of our PolyMax PC. So the end point of what you need is much more important than maybe some filament that could work. So that's usually how we work with our customers. With our users, we ask, you know, what are you using it for? What are you looking at? You know, are you looking at printability? Are you looking at any of the different strengths of the material, chemical resistance, flame retardancy, all of this kind of thing. And then depending on the answer, then we are going to look for the best filament, because sometimes some people come to us and they are looking for very easy to print and extremely rigid material, and we want a carbon fiber reinforced stuff. And then actually our regular PLA, I believe this is regular PLA, actually has extreme rigidity. I don't know if you have checked the Young's modulus of just our PLA, which is, by the way, a very high quality PLA. The raw materials we are using is from NatureWorks InJO PLA, not a similar one that as the like the more common one. It's a slightly different one, and this one has very, very high Young's modulus. And sometimes users don't realize that PLA can do 90% of the job already. So that's why it's very important to look at what are the actual needs. And then obviously sometimes we will solve that problem with with a similar material that was suggested. But we are really trying to, instead of, okay, we need a carbon fiber reinforced PLA, we are going to go the step forward and ask what do you need it for, and maybe we can design an even better solution than just releasing the material that people will need. Although for more professional industry, they have all of these experience and they know exactly what material they need. But now there is one hiccup, is when like the automobile industry, where we design our PC PPG and PC ABS mainly for, they wanted something for, do you remember the 3D printed car, the XCV car, the 3D printed, we 3D printed most of the car. And in reality, in the automotive industry, they mainly use polypropylene to produce this part. And then obviously when you're looking to produce this part, then you're going to look for polypropylene. But they are using a different manufacturing process. And when it comes to 3D printing, if you want the end part to have the same mechanical properties as PP, maybe what's gonna go in the 3D printer will be different than PP, even though what's come out, the part that comes out has the same mechanical properties as PP. And that's actually where our nylons come from. So maybe a slightly long answer that should have been required. Okay, carbon matte finish. Yeah, actually, the carbon fiber has such an amazing finish. Check out we have PLA carbon fiber, which is actually based on our PolyTerra PLA Plus formula. And we have the best finish of all, except PolyTerra, is our PA12 CF. Do I have? Oh, I didn't bring my PA12 CF. Yeah, I thought we would talk more about PolyTerra PLA, the different colors, the PolyLite PLA. So I brought a few more engineering material, but I'm happy you guys are interested in more engineering material. But the PA12 CF has an amazing finish. I will try to post. I think there's already some pictures on social media, but I will try to post some more. It's just amazing. You barely see the layers, really. So you have an amazing part mechanically property-wise. So in terms of mechanical properties, and the printability is also awesome because it also have the warp-free technology, and the finish is just amazing. So this material is really, I mean, it has everything. It has everything. Low creep compared to nylon. Yeah, so creep, creep meaning, if you put stress on a material for a long time, whether it will start to deform or it will come back, whether plastic deformation is gonna occur or it will just go back. So, and then it's temperature dependent. So creep is something we are investigating. We are trying to create some more standard tests for all of this, because because it's a very important information to have for a real life application. So we are designing this test to understand what's the creep behavior of all our different materials. What's the difference between PolyTerra and PolyTerra PLA Plus? Great question. I was waiting for this question. So PolyTerra PLA, let me take some of the prints here. So that's our PolyTerra PLA, a lot of colors, I think 28 colors in general. So the story behind PolyTerra PLA is we wanted to find a way to design a material that could be better than PLA, but using less bioplastic raw material and more sustainable material. And then we came up with the PolyTerra PLA. Let me check that. This is our very, very, very first spool. This is one of the prototype we had 2 years ago, just so you have a look. But this PolyTerra PLA has the formula that we were looking for. So it uses less PLA bioplastic, and it prints better than a regular PLA, or at least that's what we believe. But you guys can share your experience. Why we think it print better? In a way that it produces much better surface finish. I think you may be more familiar with, you know, that kind of shiny finish that shows the layer. Oh, sorry, I think my light is a little bit too strong. But you know, when it's shiny, then you can see the layers pretty well, right? Because it reflects the light. But if you have PolyTerra, the advantage of PolyTerra is the matte finish doesn't really, well, actually you guys cannot see anything, but there is some nice picture anyway on our social media. But the matte finish really changed the output of your print, and the support removal is also amazing. We have, you know, support removal is all about the balance between your layer adhesion and how easy it's gonna be to remove the support. And we wanted a PLA for prototyping, to print some trinkets, to print some, you know, aesthetic things. So we didn't need the layer adhesion to be as high as our maybe our PolyMax PLA or our PolyLite PLA Pro or this kind of thing. So now you have a material that is just perfect for a very specific application. And the difference with PLA Plus is that over time we have improved that formula. You know, we spent 1 to 2 years developing the first formula. We released it. We had a lot of feedback on, you know, what could be improved, and then we use that same formula, that same more sustainable formula, in order to create a better version. So what is better? First thing that is better is the layer adhesion. You still have similar ease of support removal, but you have a much better layer adhesion. You have higher tensile strengths, higher impact strengths than the regular PolyTerra PLA. For, again, I precise again, for the same more sustainable formula. And it has a different finish than PolyTerra PLA. So that's why we keep the two products. This is the finish. Let me see if I can do something like this. I don't know if you can see. It has like a slight silk finish. I think you can see it well with the blue one. You see, like you can, it's also very difficult to see the layers, but not for the same reason as PolyTerra PLA. It has like a slight silk finish, but not as silk as our PolyLite PLA, right? The PolyLite PLA Silk is much shinier. It's just that fine touch that makes the model very very attractive. Actually, all of these colors are PLA Plus: the green, red, the gray, the white, the black, and the blue. So we have 6 different colors for that particular one. So I hope that that answered the question. Printability wise, printability wise is the same. Very similar settings. Is there a Black Friday sales on the website? Unfortunately, the website this year won't have particular. We do have some promotion, but it won't have a big Black Friday promotion. The main reason is what? The main reason is next month we are going to come up with a brand new website. So we put all our resources on that that new website, which will be released mid-December and December, and that will come with a lot of new things and one particular tool that I think you guys will love. But that's the main reason why the current website doesn't have exactly all our product range. There is a few products that it doesn't have because the new website will come with our full portfolio. I just bought some red PolyTerra PLA Plus for ornaments. Can't wait to get it loaded up. Yeah. Please share some pictures. And also remember the weekly live we are going to have during this every week basically. We are going to review also your projects. So we are going to go through your project. We are going to comment your project. We are going to see how you use our filaments. So please share all of that. We do have. I'm not supposed to say this, but actually we just created a Reddit community. It's /Polymaker. And there's no post, there's nothing because nobody knows, but you're basically the first one. So if you want to go and have the very first post, then in 2 weeks, we are going to start going through all the Reddit posts, and then we are going to comment. And we will also go to the bigger group, the 3D printing group, and we are going to comment people with issues. So whether it's our filament or not our filament, we are going to go through and we are going to talk material science. We are going to talk, okay, you see, these guys have this problem, how we could solve it. This guy has the problem, etc., etc. So I think this weekly live stream is going to be quite a lot of fun. Why is PA12 CF nearly twice the price of? Okay, yeah, price questions. A lot of price question, right? But yeah, so PA12 is a great material, but as pretty much a lot of things in the world, every time you want to source a great material, then it always comes with a cost. So PA12 raw material, the one we're using, is not as cost effective as a regular PA6 or 6.6. I believe it's because not a lot of people use PA12 as much as the others. So as long as you don't have a lot of scales, then you cannot have that more cost effective, budget friendly price. It might be because of the production process also, but I don't have any knowledge on that part. But definitely PA12 less cost effective than other of our nylon. But it's worth it. I mean, if you need that high mechanical property, good printability, and amazing finish, if you need that, then it's definitely worth it. Also, how does PolyMax PLA compare to PolyLite PLA Pro? Great. I was also waiting for this question. Thank you, Josia ONG. So I prepared, actually my team prepared this. So let's do some tests. Actually, do you want to see something funny? I asked whether we could print something where I can, bend and show the behavior, and and then they printed this. I think it's close to 100% infill or 50%, but there is no way for me to show you anything because it's basically unbreakable. It's too big. But because what I wanted to show you is the behavior, the fracture behavior of the different one. Then I got this one. Let me check my notes. So we have the teal one is PolyLite PLA. The red one is PLA Pro, and the orange one is PolyMax PLA. So, but they are okay. They are very low infill, so I don't know if we are going to see much. I'm putting it to the light to see the infill, but they are like I would say maybe 10 or 15% infill. So I'm not sure we are going to see much. But let's do some prediction. I haven't tried, so I don't know what's going to happen, but I know what's the difference. The PolyLite PLA, which is the teal one. PolyLite PLA is a regular PLA. So by regular PLA, I means it doesn't have any impact modifier inside, and it will just behave as being very rigid. So it's a very rigid material, but the fracture behavior is how do you call that? It's very sharp. Like if I bend it, I will arrive to a point where it will just shatter. It will just break. I'm a little bit nervous because I don't know if it's going to work. But that's supposed to be for PolyLite PLA. Any PolyLite PLA one, I believe. This is also PolyLite PLA, but I cannot break it. This I cannot break it. And I have been instructed to not break too many models. So, but that's supposed to happen here. And then for the red one, you are going to have a behavior where it's going to be very hard to bend, but it won't break. It will just have some stress whitening marks, and then it will just bend until it until I can touch my my finger. So that's what should happen. But it would be hard to bend. PolyMax PLA, it should be quite easy to bend, and it will just go all the way. It might break a little bit in the middle, but it won't break completely. You will have to, do on both sides. So, oh, sorry. I think the sun just arrived. Let me just... Is that better now? Sorry, I was not looking at the screen. I hope you saw what I was showing. Sorry, it's the morning, and then we just have the sun coming up. Okay, so let's try. So this is PolyLite PLA. It should break pretty sharp. Okay, I'm less nervous now because it's supposed to do that. So that's PolyLite PLA. Now PolyLite PLA Pro. Now let's do PolyMax PLA. I think I'm more confident that it won't do the same. PolyMax, because PolyLite PLA Pro has a very high rigidity with impact strength, so the behavior is hard to predict. But this is PolyMax PLA. Okay, so it become hard. I think PolyLite PLA was already breaking at that point. And then it's supposed to have stress whitening. Yeah, you start to see a little bit. And then I can touch. Yeah, you see? And then I cannot break it. And then I have to go back. And then you start to bend and go back. And then go back, go back, go back. Yeah, now it's break. Okay, so far we were able to predict. The last one is PolyLite PLA Pro. It's supposed to be very, very hard to bend, harder than PolyMax PLA, but it should not shatter as much as PolyLite PLA. It might break suddenly, but it should arrive further. So let's have a try. Okay, so already at that point, it's quite hard to bend. Yeah, now it's very, very hard. I can see some stress widening already, and then it breaks. Yeah, perfect. Okay, I'm less nervous now because every material behaves as it should. You see the stress widening, and then it breaks. Okay, so I summarize. PolyLite PLA, the teal one, PolyLite PLA, a very, very rigid material, very hard to print from the very beginning, very hard to deform. However, once you arrive at a certain stress point, it will just break. Okay, it will just snap. For PolyMax PLA, it's a very ductile material, and then it won't basically break. It will just bend until until you cannot bend it anymore, and then you really have to work it out to break it. So a very, very ductile material. And PolyLite PLA Pro has a little bit of both. Has very strong rigidity, very, very hard to bend, like PolyLite PLA, but at some point you will arrive at a point where it behave a little bit more than PolyMax PLA. Instead of PolyMax PLA, instead of suddenly breaking, it will just have some stress widening, but it won't be able to go all the way like PolyMax PLA. It will break before. So I'm pretty happy because this is a live experience. I mean, I didn't try this before, but I knew, I mean, I'm pretty confident with our material, so I think it behaves as it should be. So I hope this experiment shows a little bit the difference between all the different material. And I'm actually pretty happy it went as it should be. In terms of colors, by the way, PolyLite PLA comes in a wide range of color. I mean, we are talking about 12 regular color. A regular color meaning, black, white, red, blue, teal. And then it comes in silk. Silk colors, we're talking about all of these. All of these silk color. You see, we have bronze, silver, gold. There we have blue. There we have lime green, magenta, and purple. So we have all of this. I believe the purple, because this was from our test, I believe the purple has been a little bit modified before we release. So maybe the purple that is actually on sale might be, oh yeah, it's this one. Yeah, that's the actual purple. Okay, so that's the seal. So we have a lot of regular color, 12 regular color, 7 to 8 silk. And then we have glow in the dark. We have glow blue, glow green. And the glow green is very, very bright. I mean, I guess you have seen some pictures on our social media, maybe. And the blue has similar brightness as the green one. And then we have some galaxy color. So we have our galaxy red. And then we have our galaxy black and our galaxy blue. So galaxy means there is some glitter, silver glitter inside, and you can make like awesome models like this one. And then you can make the solar system. So pretty nice set of colors. So we have 3 galaxy color. And then we have the PolyLite range also have the lightweight, which I don't have here. But if you guys are interested in lightweight, please let me know, because our lightweight is very, very specific. We have a specific foaming technology that is different from other foaming materials that you may have seen around. My experience with PolyTerra PLA, I guess, is just bad layer adhesion. Yeah, so switch to PolyTerra PLA Plus if your application requires higher layer adhesion, or switch completely to our, if you need a really high layer adhesion, switch to PolyLite PLA. PolyLite PLA has one of the highest layer adhesion. So, good question. How do you define layer adhesion? Do you define layer adhesion by the absolute strength it can take, or do you define the layer adhesion as the closest ratio from Z strengths to XY strengths? Because theoretically, PC could have a very, very strong layer adhesion in an absolute number, but maybe it's only 30% of what it can do. But even 30% is still higher than what PLA can do. But if you define it by the ratio between what you can get in XY and what you can get in Z, then PolyLite PLA is one of the biggest. I think we are close to 80%. So you can get 80% of the strength on the Z axis compared to the XY. I may have to double check the number, but I think we are close to that. I use ASA and PC instead. Yeah, ASA is a great material. Weather resistant, heat resistance, not as challenging to print as people could think, but there is a learning curve. Comes in a great amount of colors now, and also the matte finish. It has a slightly matte finish compared to other. This makes it a high-five material. Will PolyMax ever get a matte finish? Also, is there a Black Friday promo code for the website? So I think the website question I already answered. For the PolyMax, I'm not sure which one you're talking about, but whether it's PLA, PETG, and PC. So PC and PETG, very hard to do. They have a shine finish by design, like intrinsic to the material. For the PLA one, we could make one. PolyMax PLA is more used for engineering application, so the aesthetic is less of a demand for our users, but it could be possible. It's not in the pipeline yet, but it could be possible. Better layer adhesion sounds great. Okay. Is PolyLite PLA Silk any different than regular PolyLite PLA? The formula itself, yes, there is a slight difference. It's not a big difference, but there is a slight difference. In order to create that, that silk finish, we do have to alter a little bit the formula. We could just change the color, but we wanted to go the extra mile to really give that silk finish. So yes, it is a slightly different formula. I think it won't shatter. The silk, yeah, that's a good point actually. The slight modification makes it a tiny bit less brittle than the regular one. So that's your experience, and that's good. Actually, that follows the science behind. Even the PolyLite isn't as brittle as other PLA. Yeah, actually, I mean, to be honest, I think a lot of people don't realize how strong our PolyLite PLA is. It may, yeah, I don't know, but I'm glad you have the same experience. But definitely, our PolyLite PLA is. I'm not sure we should call it a regular PLA. If by regular PLA we mean the average on the market. If regular PLA mean average on the market, then this is a PLA plus, and plus meaning rigidity, because usually plus means higher ductility. But yeah, we should find a new name like PLA, like super PLA, PolyLite super PLA. It's extremely rigid PLA. That was a great demo. Yeah. That was great because it worked. Will there ever be a PolyMax ABS or PolyMax ASA? Excellent question. We did have this question. Let me check. Do I have some ABS around? Or I think I have some ASA. Yeah, this is ASA. Obviously, I guess I think you can guess why we chose this model to market our ASA, right? Weather resistant. So why there cannot be any PolyMax ASA or ABS? What does PolyMax mean? PolyMax PC, PLA, and PETG. What does that mean? It means it has our nano reinforcement technology. Nano reinforcement technology means we are bringing the impact strengths of the materials to a different level. PolyLite PC, regular material. PolyMax PC, impact strength 10 times more, I think. Close to 10 times more. PolyLite PLA, regular impact strength, like I think 2 kilojoule per square meter, square centimeters. And we bring that to 12 kilojoules. So I think 6 times regular PLA. PolyMax PETG also bring, I think, 5 times higher. Now, what's the problem with ABS and ASA? Well, their impact resistance is already high. And the technology we have doesn't multiply the toughness of the material. It just brings it to a certain level. But if the material is already around that level, then our nano reinforcement technology is not gonna change so much. I will explain why in our weekly live stream. I will explain, I can go more in depth in what is the nano reinforcement technology and why it cannot just magically multiply the impact strength of the material, but it can just bring it to a certain point. So ASA and ABS already have a high impact resistance, a high ductility, high impact strength. So it's very hard to go higher with our nano reinforcement technology. So the answer is no, there won't be any ABS and ASA in the PolyMax family. Also, by the way, Josiah, thank you very much for all your questions. That's awesome. Also, is PolyLite PLA lightweight similar to PolyWood mechanically, and will there be PolyMax PLA lightweight? Another great question from Josiah. So, yes, PolyLite PLA lightweight is similar to PolyWood. This is our PolyWood. We noticed that a lot of users were using PolyWood not because it's a wood mimic filament, but because it's extremely lightweight and easy to print. Okay, why easy to print, right? Am I biased or do I have some arguments behind? So I do have, I believe, what is an argument that says that our foaming technology has advantages compared to other. You have to make the difference between active foaming and passive foaming. So what you generally see on the market is active foaming. Active foaming means you have the filament, you will print with the filament, and the temperature at which you will print will define the foaming rate of the material. So it's going to foam during the printing process. What inconvenience does that give? Well, you have to, it's temperature dependent, so you have to find the right temperature for your right purpose. Depending on the foaming, it might increase the width, it might increase the volume. So you have to tinker your slicer in order to print. Sorry, I'm out of saliva. You have to increase the extrusion multiplier in order to compensate that foaming. So that creates some issue. And what's the biggest issue? The biggest issue is if you're using an active foaming technology and you want a very low weight, a very low density, then you have to print at 250 or 260. And then you have new problem, stringing problem, artifacts on your print, flow management that becomes harder because of the very, very low viscosity. So you have all of this problem. Now comes PolyWood. What's PolyWood? Well, PolyWood is not an active foaming filament. It's a passive foaming. Passive foaming means we already foam the material. So when it comes on the spool, it's already foamed. It's already half the density of regular PLA. That means you just plug it on your printer. You print with exactly the regular setting of your regular PLA. You might change a little bit the retraction setting in order to have a very nice finish, and then that's it. Then you have your print that is half the weight, almost half the weight as regular PLA. So that's the biggest difference. From history, from the background, the PolyWood was created because the wood mimic filament on the market has this wood powder inside. What's the problem with wood powder is that it would clog the nozzle. If you have an accumulation of this wood powder, then it will just clog the nozzle. So we wanted a way to create a wood mimic filament that doesn't have any clogging problem. Well, what's the best way to solve the clogging problem? You remove any wood powder. So we remove all the wood powder. Now that's the problem. Well, it doesn't look like wood. Well, what is wood? If you put a piece of wood under a microscope, then it's like a cellulose, it's like a cells network, right? So what to do? Well, you take your PLA and then you make the same macrostructure. And how we do that? The cells you create with foam. So now we have a material that has the same macrostructure than wood. And what's left? Well, the color. So we make a wood color. So now you have, by definition, a material that is wood mimic, same macrostructure and same color, but doesn't have any of the clogging problem. So that's kind of the history of where this material come from. And then now you have the whole lightweight industry that is very interested in that material just due to its easy to print. You can actually check on YouTube. There's a guy that is passionate about RC plane, and he's designing RC plane with a regular lightweight PLA, and now he just discovered our lightweight, and he's explaining about all the difference between the two. Very interesting video. Will there be any PolyMax PLA lightweight? Yes and no. No, it won't be PolyMax PLA lightweight. Yes, we are working on a tougher version of our regular lightweight. So the lightweight, what's the issue? Because it's a foaming technology, because it's a foam filament, the mechanical properties are reduced, right? You have less material, you have less density to take stress, but we are modifying we are optimizing our formula in order to create a better lightweight material. or other forming filament. Yeah, we do have other forming filaments, so different color currently on the pipeline, but we do have some, like I said, an optimized version of lightweight filament. And actually, we can also do, you know, we have a 50% lightweight, we have a 70%, we have I don't know, percent, well, 20%. There's nothing, but you can have like different rate of forming. Actually, if you go on our Amazon, there is one material that I don't think you can find it randomly, but there is a foam TPU which is in beta testing. You can find it, but it's please be aware, it's very hard to print. It exactly like foam. When you print it, it's like a piece of foam. It's a TPU with the foaming technology. It's in beta testing because we don't think it's ready to the market because it's not easy to print. It's really not easy. So please be careful. If you go with that material, if you decide to purchase the material, please make sure that you understand the challenge behind. But just so you know, there is a couple of filament that is hidden in beta testing. I define it by a percentage of X, Y to Z. Yeah, so I guess you are talking about the layer adhesion. I do think that's a much better definition of layer adhesion than just the tensor strength on the Z-axis. What about PolyLite PETG and PolyMax PETG layer adhesion? PETG, by definition, has the best layer adhesion in a way that it's one of the material that untangle very easily layer to layer. That's what actually, from my experience, from what we have found. So it is. So if you are talking about the difference, they have similar layer adhesion, but PETG, the polymer compared to other, should have a higher layer adhesion. The only issue is it's more challenging, slightly more challenging to print than PLA. So PLA reached its top performance much easier than almost any other material. Hey Musadi, how are you? So there is one in the chat, Musadi Shah. Very informative session. He's one. He's in the R&D team, and he's one of our engineers that deal with all our product data. So all the data I'm explaining right now is managed and come from Shah in the chat. What about PolyLite ASA Pro or PolyLite ABS Pro? Yeah, same reason than PolyMax. However, it's a good point in a way that Pro is a great mix between rigidity and ductility, or let's say ductility and impact resistance. So maybe we could have an ASA or an ABS that doesn't bend as easily. So it keeps the impact resistance, but it's much more rigid. Yeah, that's a very good idea, actually. That's an idea we should investigate. You may see a PETG Pro, an ABS Pro or ASA Pro. Very good idea. I will have to put your name on the spool. Imagine PolyMax ASA with an impact strength of 40 kilojoules. Yeah, so like I explained, it doesn't multiply the absolute number. It just reach an absolute number. So if it's already at that number, then it won't move. I just realized how many questions I asked. Yeah. Thank you for this question. I didn't realize, but it's already 1 hour and 20 minutes. But I'm very happy. I mean, I have, it's Saturday here, so I have whole day. I will make sure that every single question have an answer. If I had to pick only one, prefer when layer bonding is defined as an absolute standard across all material rather than a ratio contained within a specific individual material. We need both. If you had to pick one, so you mean I prefer when layer bonding is defined as an absolute standard across all material. So you mean which one has the highest absolute number, I guess? I prefer when layer bonding is defined this way. Okay. We need both. Okay. From the data, if I remember well, actually, we share all our TDS, right? We're very transparent about anything. when we released our PolyTerra PLA, the compostability was a big point, and we released the compostability report, we released the certification, we released everything. So you do have access to all the data if you need. But I do remember, I think it's PA6 CF that has the layer at the highest layer adhesion, absolute layer adhesion from the data. But it highly depends again on your printability, because CF, the carbon fiber, will limit that layer adhesion, right? Any fiber reinforced material. Outside of reinforced material, let me think. I think it should be CoPa. It should be CoPa. I would have to double check, but it should be that material. I think this one has the highest Z tensile strength. So the tensile strength in the Z axis. I'm sorry if I'm wrong, but I do believe from memory of all our material TDS that this one has the highest one. Absolute number. Actually, I forgot, but our TPU, in terms of ratio, I think also has one of the highest Z adhesion, like XY compared to Z. So you know why we printed this one in flex is because we kept breaking it, and then we were thinking, okay, we need to print with a tough material, so we are going to print with PolyMax PLA. But then we thought again, do we need rigidity? Do we need any kind of impact strength or something? Well, no. The only thing we need, it doesn't break. Then if it doesn't break, if the need is it doesn't break, then let's just print it in flex. So that's flex. So it doesn't break. So I think that's supposed to be the length, I guess, somehow. Like here. So yeah, that's CoPa. The answer is CoPa. Will there ever be PA11 filament? Never seen a PA11 filament, but have heard of PA11 powder, so why not? Yeah, so I think SLS has PA11, but no, we haven't really started on this. I actually don't have any knowledge about PA11. I mean, I could understand what it means, but I don't understand. I don't know enough about that material. Also, will there be any metal composite filament? Not really. We don't have, because there's two kind of one. The one for the aesthetic purpose, the one with the metal filler, so that you can polish the material and then it looks good. And then you have the one with the with metal powder, and then you use the polymer to bind, and then you can cure that part, or you can sinter the part in order to have the actual metal part. But we are not in either direction. Actually, BASF has this metal infused material, and people are using it with our polycast in order to support that material. So it's like two filament manufacturers working together on a solution. So we are working on that polycast. So it was from what's the name of the company already? 3DQ. 3DQ has came up with that idea, and a very brilliant idea of using polycast as a support for that particular material. But no, as a company, we are not currently working on this material. What application would PC ABS have over PolyMax PC? Their toughness seems the same, and PC ABS has lower tensile strength, but not much more flex. PC ABS has, so PC ABS is kind of the history come from injection molding industry in the automotive industry. So it comes from there. It has the processability that other regular PC doesn't have. In terms of exactly what application would only work for PC ABS and what application would only work for PolyMax PC, I don't think there is a straight answer for that. They behave similarly, even though PC ABS is more challenging to print and has higher heat resistance than the PolyMax PC. And the finish on PC ABS is also different. PC ABS allows the how do you call that? You know, the metallizing. You know, where you vacuum metal sheets, or no, how electrolyte. You know where you have that that metal coating on that PC ABS. So that's like some slight features that they have in difference. Santiago, you ask our engineer if we could include the stress strain curve of the material. We actually had it. The problem is, for some material, the exact curve is sometimes sensitive information if the way we are testing it. So that's the main reason why we remove it from the TDS. But you should have information that allow you to estimate that curve. We could also give the toughness area of the material. That could be a great information as well. Also, could you put the amount of moisture before major strength and quality reduction in the TDS? I believe it should be already the amount of moisture before strength and quality reduction in the TDS. I think they should be. Oh, so you mean the moisture, the moisture content of the material straight before the yeah, okay, I understand. Okay, yeah, there's many data that we could add. We are trying to make the best TDS. That's why now the TDS is version 5.2. We went through a lot of version, adding information, optimizing information. So thank you for the recommendation, the suggestion. I find PA6 GF has a layer adhesion so good, it tears when there's a little bit of moisture in the part. Sorry, I'm not sure I understand. It has a layer adhesion so good, it tears when there is a little bit of moisture in the part. So it's so good, or it's not good? Like, it's good when there is no moisture, and then it's good when there's no moisture, not good when there's moisture. Sorry, I didn't get it. Moisture data, okay. Yeah, so the engineer is in the chat. So any suggestion on what to add on our TDS will be recorded. Could you use PolySmooth as a soluble support? Yeah, you could. Talking about support, I have some models around here. I have poly support models. We can try to remove supports together to see, you know, the breakaway. You know, how good is breakaway? I do have some water dissolvable material as well. So we used to have, stick together. So we used to have an alcohol dissolvable material. If you check on YouTube and you check Polymaker SO3, I believe that was the name of the material. But so the goal was that it's a non-moisture sensitive dissolvable material. Sorry, out of saliva again. Because the problem with PVA is it dissolves in water. So obviously the filament also dissolves in water. So it absorbs moisture and then it becomes hard to print. But that particular material that was IPA dissolvable was based on PolySmooth. You can still use PolySmooth, but it will not dissolve 100%. It will just dissolve enough so that it's easy to remove. It will kind of become like a very gluey. So the answer is yes, but it won't be as good as a PVA. So if you check PVA, you see, that's a model I designed to test our support material. You see like a very sharp overhang, a completely dead flat part, and then a part that would warp on the support, because the support has to be strong enough so that it doesn't warp, right? And so we tested all of this in that material. So that's PolyDissolve S1, and then that's also PolyDissolve S1. So you see the idea we have here. This is a dinosaur. This is a T-Rex, but we always recommend to put it upside down because it requires less support, like that if you would print like this. You get what I mean? Like this. And then we have our breakaway support. So the breakaway support is so satisfying. You see? I won't break everything because I want to leave it for our next live stream, but it's so satisfying how you remove, because it has, look here, the interface here. Let me check. You see? Perfect. So this is how easy it is to use. And then I will keep this one. We can remove it live in the weekly live stream. So this is about a little bit about support. Breakaway support, poly support, and PolyDissolve S1 water dissolvable support. So this water dissolvable support works for PLA, Nylon, CoPa, PolyMide CoPa, TPU, PETG, but not for all models. Have to be careful with PETG. Also work with PVB, a tiny less than PLA, but also work with PVB. Poly support works very well with polycast and polysmooth. Right, I remember PCABS has a different finish. Yes, electrolysis, I believe so. I think that was the name for PCABS with with the metal coating. I boil my CoPa prints to get the flex and durability I need for my products. TPU 95 is too soft and all other too brittle or high heat sensitive. Are you planning a material that can fill this gap? Well, it looks like you already filled the gap, right? You boil your CoPa. So what is the gap left? I need my product. TPU is too soft and the other are too brittle. Someone in between. Well, if you wouldn't have talked about the CoPa, then I would have said the CoPa is in between. But if you want one that you don't have to boil, then we have one material that is in the pipeline and will be released Q2 next year. That is almost exactly defined by being in between. But currently, I think CoPa, you boil CoPa, you know, the CoPa, if you boil that, it will become you know, very, not very soft, but a very ductile material, very, very high toughness. So I think the solution you have found is already very good. Oh, electroplating. Yeah, that's the word. It tears, doesn't snap. Yes, the PA6 GF. Yeah, so layer adhesion, the comparison between X, Y, and Z, you could try to break the part and see, you know, where it tears. So if it tears, I believe is along the layers, which you can, you know, try to improve with maybe higher printing temperatures. But I think I get what you mean now. It's very ductile. Yeah, okay. PS6 GF has a ductile layer Z-axis break. Yes, okay. Can poly support be used mechanically? The TDS doesn't show mechanical properties, just support removal properties. Yeah, because it's mainly designed for being a breakaway support. It is a great material. Actually, it is a pearl. It is a pearl finish. Well, it is a pearl finish, so it's hard to show with such a big light, but you can use it. I think I have some picture where we use it for the actual product, but yeah, it's supposed to be for breakaway. But if you want to use it, if you want a reason to use it for actual material, then it would be because of the pearl finish. Will there be a rigid TPU filament like Armadillo? Yeah, there will be. And actually, that's the answer to Peter's question. So I won't be able to talk too much about it. Will there be a recycled PET or PETG filament like BASF? I don't know BASF. I think BASF is a PET, right? You know, it depends on what recycle mean. You know, there's a lot of recycled filament on the market, but what they do is they use the waste from their production. You know, when when you purge your extrusion line, or where you have a low yield, when you wind product, or when you have some issue, then you just put it back in the hopper. So, and then they usually call that, recycle. What we are trying to do is recycle by taking waste from other industries. Like, for example, the 2 kg spools that we have for PC, for PA6 CF and GF. That spool is made with a mix between PC ABS, and this is recycled waste from the electronic industry. Our PCR, recycled PC, is waste from the bottle industry. So we are trying to do this way. And in order to do that for PET or PETG, then we are working currently with a company that recycle waste PET from the ocean. And there is a company that do that. I don't remember the name, but I think it's ocean-related name, and from fishing line, and then they make some filament, which is an excellent idea. So we want to have a similar way to use waste in order to create filament. What's the biggest challenge on doing this? You have to control the quality of your supply chain. If everything comes from waste, it's very hard to control that quality. So we worked with Covestro in order to make that recycled PC, and they can provide that reliability in terms of recycled pallets. So we have to develop that capability for other materials as well. Will there be a lightweight nylon? Just curious. Not in the pipeline at the moment. Nylon is usually used for mechanical properties. So the lightweight will really affect that properties. Also, how different will the properties of ESD PolyMax PETG than regular PETG? Okay, so it would be much, so it would lose a little bit its impact strength and gain in rigidity. So you can see ESD a tiny bit as carbon fiber reinforced, but without that extra huge mechanical property that carbon fiber usually have. So you can see it a little bit this way to understand what would be the difference. I'm kind of losing my voice a little bit. It's been 1 hour and 40 minutes, so I will just go through the rest of the questions. And then I think if you really like that kind of content, then I will just see you in 2 weeks during the weekly live. So I will just finish the question. Now that you talk of production, a factory tour would be cool. Just an idea. Yeah, definitely. Actually, there is a guy on Instagram called Dronozor, a French guy, and he has he made all of his drone using PolyMax PLA, and he's shooting a lot of videos, traveling around. And I really want him to come to our factory and with his drone just go, because our factory is huge, and I want him to go with the drone, following all the filament path and then going the warehouse, etc. That would be awesome. But yeah, it's a very good idea, and I hope we will have this very soon. Will there be carbon fiber nanotube nylon? Not in the pipeline at the moment, although we have a similar material, but not that particular one. Thank you. That's great to know. I rather not have to boil. Yes, yeah. So next year we will have one that would have similar properties as a boiled nylon. Will there be FR version of other filament? Yes, there will be. There will be in the PolyMide family. Okay, sorry, I went a little bit fast for the other questions. Thank you very much for joining the stream. Again, we have our Black Friday sales going on. You have the link in the description of this live. If you have any other question, post it on any social media. We are on Twitter, we are on Facebook, we are on Instagram, we are on LinkedIn, and we are on YouTube. So any post that has the word Polymaker in it will most likely be answered. You can tag us to be sure to have an answer. So any question, please feel free to ask. Until then, I wish you a very good evening for the people in the US, rest of the day or the night for people in Europe, and a good Saturday for people in Asia. Thank you very much for joining again. And then I will see you in 2 weeks for the weekly live stream. Thank you very much again.